Okay, so here is where we are. We have done a lot of work in this course so far, talking about how to solve traditional AI problems. What is a traditional AI problem? You cast it as a search problem, and the reason you cast it as a search problem is because you want to reach some goal state, or you want to reach some state where some constraints are satisfied. We can think of it as a goal state. In some cases the path to the goal is important, in some cases the state itself is important. The world is mostly deterministic. You know the consequence of each action exactly, and then the question is how do we solve such a problem, and why we solve such a problem is because it is a general problem. You can use that framework to formulate pretty much any deterministic problem in the world, single agent. And we also did one extension of it in the case of adversarial setting, where there was uncertainty in what the opponent is going to play, but this uncertainty was of a very specific nature that we knew that whatever we are trying to maximize, the opponent is trying to minimize. So, that was a very specific situation. There we did the search algorithm. Then we said, that is good, but of course, this would not lead us to a very strong AI system. We need to give knowledge to the AI system. And we started giving knowledge to the AI system, and we did two main knowledge representation languages. The two, I would say, were relatively most popular knowledge representation languages. One was the language of logic, and one was the language of probabilistic graphical models or Bayesian networks, right. And in logic, we did not do first order logic, and there are many different kinds of logics. There is a full, say 70-year history in logic, and so there is a lot that goes on in the field of AI in logic, but we touched on that. And then in the last 20-25 years, there has been a lot of work in probabilistic models, and we talked about that. And in this knowledge representation language, we will express the world, or how the world behaves, how the state variables in the world or random variables in the world interact with each other, and what should be true and what should be, how should we change our belief, and then we could do inference on top of it. And we learned several inference algorithms that, given a new query, can tell you whether it is true or false, or what is the probability of that, depending upon which knowledge representation language we are talking about. I would say these are two different pieces that we have studied. One is the search algorithm and decision making in deterministic environments, and one is knowledge representation and inference algorithms in both deterministic and probabilistic environments. So, therefore, what remains, the most critical part that remains in terms of the big picture, is decision making in probabilistic environments or uncertain environments, right. And uncertainty in AI divides traditional AI and modern AI. So, if you go back, starting 55 and so on and so forth, a lot of the work that kept happening until 80s was using logic representations, was using deterministic environments and deterministic scenarios. It is not exactly true, but this is an approximate sort of high level bit. But starting the 90s, starting when Udia Pearl started giving his points of view, starting with them, and then leading up to full all of 90s, a lot of 90s, all of 2000s, the world was mostly probabilistic. Life was probabilistic, AI was probabilistic, and that I would consider modern AI. If you really want to fine grainedly split it further, I would say phase 1, phase 2, phase 3. Phase 1 was logic, phase 2 was probabilistic, and now you can say that phase 3 in the last 5 years is neural, right, neural networks, deep learning. And we will touch on that towards the very end of the course. This is also a gross approximation, because neural networks has had two other lives earlier. It came up, it went down, it came up, it went down, and then it came up again in the last 5 years. Maybe this time it is here to stay, who knows, right? We do not know. This has happened with neural networks many times, and we will talk about that when we get there. So, today's world is not only probabilistic, it is probabilistic plus plus, and this plus plus part comes from the neural models, but we will get to that when we get to that. Let us talk about uncertainty in AI, which has been a significant theme in the last 20 years. And you have to realize that uncertainty in an environment comes from many forms. And what was happening, and we discussed this sometime at the time of Bayesian networks also, that logic is brittle. You cannot describe everything in your language, and if you can't describe everything in your language, then your logical systems cannot handle many scenarios that actually occur in the world, and because of that they are just not able to scale up, right, or scale up, or as in give good performance, right. And uncertainty comes in many forms. So, if there is a multi-agent scenario, you do not know what the other agent is going to do. In fact, in minimax we assume that what we are maximizing, the agent is minimizing, but in practice the agent can do anything, right. If you make a game bot of yourself, you do not know exactly what the opponent is going to do, and so you have to be able to respond to them. In fact, some people try to learn what kind of mistakes the opponent's bot is doing, right. And so that also is part of, there is uncertainty, and let us try to figure this out. Uncertainty in the outcome of my own action. I try to do something and of course I fail, or I end up with unusual consequences, and we have discussed this example several times, that I have a physical robot which is acting in the world. It wants to get to location 10, 20, it may not reach exactly 10, 20, it may reach 9, 19, right, or 21, 21. Oh no, that is too bad, 11, 21. Right. So, you do not know exactly where you are. If you are playing robo soccer, you do not know exactly where the ball is, right. Did I give you this example where once upon a time this dog, a Sony dog which was playing soccer, kept going in circles like this, and nobody understood what is going on. Why is it not playing football? Why is it going in circles like this? And suddenly it was just basically rotating on its z axis. And then what later people realized that look, the ball was orange and it was programmed to track the ball that was orange. So far so good, but in the audience there was a guy wearing orange shirt which was just moving around, doing something, and the dog thought that that orange shirt person is the ball, and it was rotating on its axis trying to track the ball. There is uncertainty in the real environment, not necessarily because the environment is uncertain, although sometimes it is. You may change seats, you may talk to the other person, there is uncertainty, you have to constantly keep track of it. But there is also uncertainty in the sensors. Even if the world is deterministic, you may not get to know it exactly, right. You may only have some probability distribution about where you are, where the ball is, and so on. So, uncertainty in my knowledge of the world, therefore, where is the ball? That is also another kind of uncertainty. And then later we will study uncertainty in the way the world evolves. We do not even know how world evolves. If I give you an assignment, whether I am going to do hard grading or easy grading, you do not know this. Your seniors may have told you something, but that changes over time also, right. I also evolve. So, the world evolves around you. The dean in the institute changes and suddenly they bring new rules. You can't predict exactly how the world evolves. You have to somehow make sure that you are safe, right, etc., etc. So, there is lots of different uncertainties in the world that we somehow have to grapple with and deal with and handle. And today we are going to start talking about the uncertainty in the red primarily, that is uncertainty in the outcome of my own action, and coupled with uncertainty in the knowledge of the world. Okay. And so, we will take a very simple example, but then after a couple of classes we will build it into a full blown model of Markov decision process, but today we will not. We will just start talking about decision theory. Now, decision theory is this full field which studies how agents should make choices. It also studies sometimes how people make choices, but that is a different story in general, because people do not use decision theory in making their choices. We have discussed it time and again that people, humans, sometimes emotionally make a decision, and then later if you ask them why did you make a decision, they will cook up a story. You have done it, I have done it, we all have done it, this is the way we work. I am not saying this is good, this is bad, this is just who we are, but we can't give this to the machine. We can't have the machine take random decisions, kill itself, commit suicide, break the vase, throw water on the floor, we do not want machines around us like this, we have people for that. So, machines should be taking reasonable rational decisions, and this is what we had decided long time back. What is the definition of AI? It is rationality, long term rationality in its actions. This is sort of what we had decided once upon a time, right. So, in light of that, we want some theory on how should the agent take decisions, right. And decision theory lays out the principles for how an agent arrives at some optimal choice or an optimal choice or a choice near optimal or whatever best it can do in terms of bounded rationality. And again, I want to re-emphasize, I have done this twice already in the course, so I will not belabor it, but good decisions may lead to bad outcomes. That does not make the decision bad, and bad decisions may lead to good outcomes, and that does not make the decision good. So, you took a completely crappy decision, suddenly stars became lucky, I mean for you, and gave you the right best cards and you won, or you did something, or you got lots of marks. You only studied one chapter for the exam out of 5, and for whatever reason 60% of questions came from one chapter, and initially you did not know that this is going to happen, but then you are very happy, I did the right thing, I only studied one chapter. That is foolish thinking. You still got lucky, you still got good, probably good marks, but that does not make your decision correct. And so, it is important to distinguish how the world worked out for you, or whether it did or whether it did not. A lot of people you will find are very unhappy in life because the world has not worked out for them the way they wanted it to work. We will keep that on the side. World works sometimes and it does not work sometimes for different people. But the question we are asking is not whether the world worked for you, the question we are asking is whether you took the right decision at the time or not. And if there is some information that you get after taking the decision, which worked or did not work in your favor, that does not mean your original decision right or wrong. That has no bearing on your decision. Your decision needs to be taken based on what you know at that point in time. And still, if you may make a terrible decision, it is still possible to take a bad decision. So, let us look at what is the formal mechanism for how we decide on a decision in decision theory, and the steps are very simple. We will first list all the possible actions. Now, this is something I have found as a difference between rational-ish people and emotional-ish people, right. There are people who would say, I cannot do anything about it, therefore I am unhappy. It is a very good question for you to think about. Is this a fair enough statement? Should you alternatively not say that because I can't do anything about it, let us forget whether I should be happy or unhappy about it, this is not in my hands, we will let the life play out as it plays out. If on the other hand there is something in your hand that you can do about, then you do the right thing. See, in our life, the only thing that is in our control is our actions. So, if there is something you cannot do anything about, that should not take too much of your thought process. It is not important anymore, because it is going to play out the way it is going to play out. The cards have been dealt. I have a friend whose son cannot process fats. It just cannot process fats. Think about a little child who cannot process fat at all. Like now this child is 12 or 13, I believe, plays games and everything, has to be given food completely, zero oil. Now you cannot, now if you can do something about it, yes, do, see the doctor, see this, see that, figure this out. Once you figure out that there is nothing you can do anything about, the only thing you can do is to figure out how to make the best, give the best life to the child. I have a friend, he is now 80 plus, he has only one hand, he lost his hand when he was 18. Maybe for a few months he was unhappy, but then today if you meet him, within a few minutes you will forget that he does not have a left hand, just forget. He has figured out absolutely everything, that he drives the car. We are talking US, so he does not have to change gears, it is an automatic, but that is all right. The only thing I have seen him not doing and I doing, well, okay, I can play tabla, he cannot, one, and two, I can talk on my phone while driving the car, which he cannot. Everything else, I have never felt that there is something he can't do. So, if, as they say, life gives you lemons, you make lemonade. So, if there is something you can't do anything about, who cares? Let us figure out what you can and work and focus your energies on that. So, the first thing you need to do is list your possible actions, because that is your space. That is the space in which you are playing, that is the space in which you are making a choice. If it is not there, it should not even be part of your thought process ideally. Of course, now with each action you identify the possible outcomes and list the payoff, profit or reward, same thing, we can call it in different ways, payoff, profit, reward, cost is negative of reward, you can list that out. And then based on the knowledge that you have, select one of the decision theory models and apply the model and arrive at the decision. This is how at least you will do it in the machine.